Today, we're going to understand what equivalent ratios are by making tables and then graphing those points on a coordinate grid. And if you've been following along and working in your workbook, the previous chapter we looked at what are ratios, and we know that they are comparison and that we can be either comparing a part to a whole or a part to part amount. And if you haven't watched that video, it's linked in the comments below. And if you're looking for your own copy of the complete 6th grade workbook, you can also get that in the link below. Let's look at our vocabulary for today. Our first vocabulary word for today is scaling, and this is the process that we use to basically make equivalent ratios. It's the process of multiplying or dividing both terms, the numerator and the denominator, or the first term or the second term of the ratio by the same number so that we can create an equivalent ratio. Next, we have a coordinate plane, and a coordinate plane is the grid that we use to graph ordered pairs, an x and y value, and our x-axis is the horizontal number line, and then the y-axis is the vertical number line, and so this grid creates our coordinate plane. I just mentioned this word, ordered pair. An ordered pair is a pair of numbers, x and y, used to locate a point on a coordinate plane. So we're going to be graphing ordered pairs on our coordinate plane. The x term is your horizontal movement. So your first number is going to tell you to move to the right or to the left on the horizontal number line. And then the y point, your second value, is going to tell you your movement on the vertical number line. Positive, you're going up, and negative, you're going down. Constant proportionality is the number you multiply to get from one term of a ratio to another. So it stays the same across equivalent ratios. So staying the same is why it's constant, and then it's proportional because they're equivalent ratios. So our focus for today is to recognize and generate equivalent ratios using either multiplication or division, and then we're going to represent them in a table and or on a coordinate grid. And so really the big idea of today is to see that equivalent ratios show the same relationship even when the numbers look different. Let's engage in our math mindset moment real quick. And if you're working in your workbook, this is a part of each chapter in each workbook. And so we want to be thinking about same relationship, different numbers. And again, as we're understanding more about equivalent ratios, we can think about it just like a superhero who wears different disguises but is still the same person. Like I like to think of Batman and Bruce Wayne. It's the same person, and a ratio is similar in that it can be written in many ways, but it's still telling the same story because it has the same value. So when you understand how ratios can scale up or down, and we do that by either using multiplication or division, we start to see patterns. And you'll see this in recipes, road trips, robotics, all around us. It's about matching numbers and understanding the structure behind them. And this is why it works. And that is always the big idea as your Math Marvel mentor, is to make sense of the mathematics, not only knowing how something works, but why it works. So let's look at our first problems for today. Fill in the missing value to create an equivalent ratio. And so remember, as we just went over our goals and vocabulary for today, that we talked about scaling ratios by either multiplying or dividing. And so we see here that if I'm going from a 2 to 3 ratio, my relationship for this first term, I'm noticing I am given the second term, so I'm thinking about what's my pattern to scale from 3 to 6. And I know that 6 is twice the value of 3, so I'm multiplying times 2. And we're simply going to do that with each term, and we're scaling up because we're using multiplication. So 2 times 2 would give us 4, 3 times 2 gives us 6. And so a 2 to 3 relationship would be equivalent to a 4 to 6 relationship. So we can scale up and we can also scale down, which is what we'll see here with 4. So we have a 6 to 9 ratio, and then we're finding the missing first term again, but we see our second term is 3. So I can see that my number is decreasing from 9 to 3, which is why I'm going to divide. And because I'm fluent in my multiplication facts, it's easy for me to recognize or recall that 3 times 3 is 9, and I can easily divide by 3. 9 divided by 3 gives me 3, and 6 is also divisible by 3. 6 divided by 3 gives me 2. So a 6 to 9 ratio is equivalent to a 2 to 3 ratio. And so we can see here now, if we're comparing number 1 and number 4 together, 2 to 3, to get from 3 to 6, I had to scale up, right? To go from 9 to a 3, I had to scale down, which is why I divided. Okay, so as we're scaling up, we're multiplying, and then as we're scaling down, we're dividing. We can go in either direction depending on the set of numbers that you're given as your original ratio. So now we're just going to practice this idea of equivalent ratios by building them in a ratio table. Again, we're working directly out of our 6th grade complete math workbook, and so you can get your own using the link below. So we're on number 1. $15 per hour, and that's our first ratio. So for every dollars to 1 hour, and then I am going to fill in for there. So in this case, I'm going to scale up and times 2. So that would be 30. That would be 2. And for each, I could continue to multiply times 2 with my new answer. And make this 60 and 4, or I could go back to 15 and multiply times 3. I would get 45 and 3. So all that matters is that you're consistent with what you're doing for each term. So we would have 45 to 3, 60 to 4, 30 to 2, or 15 to 1. Let's try number 2. We're going to keep on going with building a ratio table. And we're going to start with what we know, which is in 1 foot, there are 12 inches. So there's 12 inches in 1 foot. And on number 1, we did our scaling up by multiplying. So we're going to start this one by dividing. If I divide 12 by 2, okay, I'm going to take half of a foot. 1 divided by 2 gives me 1/2 of a foot. Oops, that's a 2. Which is equivalent or equal to 5/10. So half of a foot is the same as 6 inches, right? And if I divided again by 2, I would have 1/4 of a foot, or 1/4 is the same as 3 inches. So 3 inches would give me 1/4. So we can scale down by dividing as long as I'm dividing by the same value for inches and feet, then we can maintain equivalence. Okay, so 12 divided by 2 gives me 6, 1 divided by 2 gives me 1/2, 6 divided by 2 gives me 3, and 1/2 divided by 2 gives me 1/4. And then we could also scale up. So if we start, I'm going to scale up in red. If we go back to our original relationship, 12 inches to 1 foot. Okay, I can double that, so I'm going to multiply both by 2. So 12 times 2 would give me 24, and that would mean that in 2 feet I would have 24 inches, or in 3 feet I would have 36 inches. All right, now we are going to create a table like we've just been doing, and we're just going to add this extra piece here to graph each point. And I want to start with number 7, just because I feel like water and rice is such a well-known real-life application of ratios. Anytime you're cooking rice, you need double the amount of water. So for 1 cup of rice, I would need 2 cups of water. Okay, and then to fill in my table, if I wanted to double that again, if I want 2 cups of rice, then I would need 4 cups of water. Okay, if I had 3 cups of rice, I would need 6 cups of water. Let's say I'm making rice for a huge party of people. I want to 10x my rice. So for 10 cups, I would need 20 cups of water. Okay, so as long as I have the same thing happening, 2 times 10 is 20, 1 times 10 is 10. Okay, now that I have my points, I'm simply just going to graph them. We're going to let water be x, and I'll do rice in y. So remember, y is our vertical number line up and down, and x is our horizontal number line. So my first point, and I'm going to actually write them over here, we have 2, 1, 4, 2, and 6, 3. That's what we'll graph, and we can zoom in here. So for 2 cups of water, I would need, so I'm going to count over 1, 2, I would need 1 cup of rice. For 4 cups of water, I would need 2 cups of rice. And for 6 cups, 5, 6, I would need 1, 2, 3 cups of rice. So we can see the consistency, right? As we plot our points here. Again, our last one, 20 to 10, we would just go all the way. Water is 20 is going to be way over here, and then 10 would be up here. Okay, and we can see that constant proportionality with each of our points. Today you learned how to represent equivalent ratios in the form of a table and then by graphing them on a coordinate plane. And we saw that equivalent ratios can be created or formed by either multiplying or dividing each term in the ratio by the same number. So I could either be multiplying both the first and second term times 2, or I could be dividing both the first and second term by 5. As long as it's consistent across the board, that's what maintains its proportionality and staying equivalent. Thanks for joining us today, and if this lesson helped you, make sure to like the video and subscribe for more weekly math tutorial videos. And if you want more understanding about ratios and you missed our previous lesson, go ahead and check out this video. See you next time.